Okay, so hello everyone and welcome to the question 2 for the tutorial of the week 2. This question is going to be about the electroplating process and how we do the calculation for the thickness of the material uh, in the electroplating process. So anyway, the example we have is from the textbook. You can see that this question is about a steel part with a surface area of 125 centimeter square. It's going to be nickel plated. What will be the average plating thickness will result if we are going to use 12 amperes are going to be applied for the time of 15 minutes in acid sulfate electrolyte bath. So just to tell you once again, remind you about the electroplating process, that's what we have. We have the cathode and the anode. The cathode is going to be the work part that we would like to cover it with the plating material. Plating material is going to be the anode. So we're going to pass the current. Okay, so the electrolyte is going to allow the atoms to be transferred through the liquid, and then there's going to be built up over the work part. So we're using what we call the Faraday law. It's about how much current is going to be passed, how much time is going to be used, and then how much thickness is going to be resulted. So we're going to go through the concept of that. What will be the calculations? What will be the solutions hints for this one? You're going to have this question in the quiz. So we start with the solution hint is about the volume of the metal to be plated is equal to the C multiplied by the I multiplied by the T. C is a constant, I is a current, T is the time. That's what the Faraday law says. So the V is the volume of the metal plated in cubic millimeters, or can be in cubic inches if you use the IP unit. C is the plating constant, which depends on the electrochemical equivalence and the density, and the units is going to be in cubic millimeters per ampere seconds, or it's going to be inches per ampere minute. I is the current in amperes. T is the time during which the current is going to be applied, and this will be in second. We can use it in minute in case if we use the IP units. The product of the I times the T, or the current times the time, is the electrical charge passed in the cell. And the value of the C indicates the amount of the plating material deposits onto the cathodic work part per the electrical charge. We always going to have the efficiency, and this efficiency should be considered. So the actual volume is not going to be 100% like what we have in the first equation. If we're going to take the cathode efficiency into account, then the equation of the volume will be edited to the efficiency multiplied by the plating constant multiplied by the current multiplied by the time. Now we have a table to find the value for the E, and that's what we are going to find in the next page. Now finally, to calculate the average plating thickness can be determined from the following equation. It's going to be the volume divided by the area. That's obvious. Now let's check the units. Here we have the volume in cubic millimeters, the area in square millimeters. So we're going to end up with the thickness, which is going to be in millimeter. Now, to find the value of the E and the C, it's depend on what is the plating material and what will be the electrolyte material. Doesn't matter what will be the work part material. So the table 28.1 can tell us what will be the plate metal, the electrolyte used, then what will be the cathode efficiency, and what will be the plating constant, which can be in SI unit or it can be in the IP unit. Now let's go back to the example. So you can see in this example, we have a steel part. We have a surface area of 125 square millimeters. We have a nickel plated. What will be the average plating thickness will result in 12 ampere, which is going to be applied for 15 minutes in an acid sulfate electrolyte bath. Okay, now I'm going to highlight the items. I have a steel, doesn't matter. I have a nickel plated, so nickel is a plating material. And we're going to use the acid sulfate electrolyte path. So this information in the red are going to help me to find the value for the E and the value for the C. Done. Now, what are the other items I have? I have the area. Okay, now the area is going to be used in the D equation. So I'll put this one aside a little bit. I have the I, the current, 12 amperes. And I have the time, which is 15 minutes. I'm going to change it later to seconds. So coming now to find the value of the E and the C, and we're going to use this table. Let's look for where's the nickel. Here's the nickel. And the path is the acid sulfate. That's the other acid sulfate. So now that's my target. The cathode, E, and the plating constant C. 95 or 0.95, which is 95%, is going to be the efficiency. And the C value is 3.42 multiplied by 10 up to minus 2. So these are my E and C value. Now let's go back to the question. From the question, we found the value for the E, the value for the C, the value for the I, and the value for the T. T is in minutes, so we need to change it to seconds. Now let's continue with the calculation. First, we find the value of the volume. Total amount of the plating metal deposits onto the part surface in 15 minutes is given by the equation of the V is equal to the E multiplied by the C multiplied by the I multiplied by the T. 0.95 multiplied by 3.42 multiplied by 10 up to power minus 2 times 12 ampere times 15 minutes times 60 seconds. And this will give me that the total volume is 350.9 cubic millimeters. Now next step is to find the value for the D. The area required should be in millimeters square. So I need to convert the A from 125 centimeters square to 125 multiplied by 10 up to power minus 4 cubic millimeters. So the average plate thickness is going to be D equal to the volume that we calculated divided by the area that we converted. So we're going to have that the thickness is going to be equal to 0.028 millimeters. That's it. That's the answer for this question. Okay, remember once again that the same question is going to be a question in the quiz number 1. Thank you very much for your listening. If you have any questions, just come back to me.